Welcome to Grid Edge Live. Looking forward to talking to you about some things that are pretty passionate about the technology. My background, so that you know, is engineering. I've been doing that for the last 30 years. My jet black hair might belie the number of years I've been doing this. But it is an engineering background I have, whether that's software engineering, network engineering, as well as systems engineering. The company itself, for those that you don't know, Bitstu, is really creating software products that allow our customers, predominantly the utility market, to gain end-to-end visibility across their operations. That could be grid operations, transmission operations, AMI operations. It's the full spectrum. That's giving us really first-hand knowledge into what is happening in the utility market, and it's also giving us first-hand knowledge into what's happening with the data issue. And that's something that you're probably all familiar with. What we're dealing with today is a pretty complex machine, as you heard in the last panel session. And that is producing massive amounts of data. That data is highly complex. I think everybody knows about the data problem. What the challenge is how do you make use of that data problem? And that's what we see firsthand with a lot of the customers that we're working with. And that data challenge is not well understood by anybody in the market unless you're facing it firsthand. Now, what we see when we go into an industrial market, like the utility space, is you're dealing with OT data as well as IT data. IT data is very well known. OT data is a completely different beast, and that's the challenge. You've got metrology information that's coming off of your sensors. You also have details such as environmental information that you have to analyze, and that could be weather, storms, anything to do with surface analysis, hydrology. You're also dealing with telemetry information, time series and event data, and the gaps that come with that. There's significant challenges because that data is now out of sequence. There's going to be gaps, timing issues. You have to correlate it. You have to really create a big picture view of that if you really want to derive value with the applications. So it's a big problem. For those of you who are facing it, we did talk to a customer last week. And that customer is now estimating that they spend $4 million on every project as a sunk cost just to deal with the data problem. So that's every project they're spending $4 million. What we're looking at is the value of information, and this is also well known. If you listen to the panel, they're really looking at data, they're looking at analytics. They're looking at distributed energy resources, looking at DG, looking at anything to do with substation automation, looking at load shaping within the distribution grid. That requires data. The value of the data is well known, but as you can see from some of the stats, including those from Green Tech Media, the ability to leverage that information is extremely hard. Now, everybody heads down certain paths, and it is contentious, and we purposely made it contentious, is if you're looking at big data solutions, you're looking at BI, you're looking at data warehousing, there are reasons that they don't work today. And that's something that we know from an engineering perspective, that these solutions are part of the picture. Don't get me wrong, but they're not the picture itself. You still have to have a data strategy in place. You have to have a data fabric. But moving data out of a historian to put it in a big data solution is just shifting the data. It's not giving you a solution. So those are key things that we start to look for. And what we're looking at now is a shift not just from the data view of the world, but to the application view of the world. Because you have to create data-enabled applications. Those are the ones that are actually going to be doing control of the distribution grid. They're applications that are going to be used by operators. It's applications that will do automation and predictive automation. Those applications have to make sense of the data no matter where that data is placed. And that data will be in a federated environment. It's not all going to be nice and neatly and tucked into a big data solution. So the applications is a bit of the focus for this conversation. And the applications are going to be purpose-built. And I think even the panel that just preceded me talked about those purpose-built applications. You will have operators that are looking at volt-var optimization. They might be looking at energy diversion, whether that be on the primaries or the secondaries. They might be looking at ways of doing load shaping or looking at synchrophraser applications. Those are purpose-built applications that make sense of the data when they need it and where they need that. So this is where the shift is moving from the data view of the world to applications that will leverage that data. And those applications need to understand, excuse me, the meaning around the data itself. What we're focused on here is creating a platform that allows an ecosystem of developers, and those developers aren't software engineers. I've been doing it for 30 years, but we want to be able to enable operators, physicists, other types of resources to be able to build applications to meet the needs of the business as they see it. So that's purpose-built applications. How do we enable it? I actually want to introduce Chris Bowman. He's one of the resources that we've had the pleasure to work with over the last few years. Chris here is surfing, and given the time of day, he's probably surfing right now while everybody's sitting in the conference. He's actually a surfer by day. He's a cool systems, power system engineer by night. And what he is doing is creating some brilliant applications. He's working with customers and other power system engineers in order to create applications around the connectivity model, around volt-bar optimization, around voltage profiling in order to drive energy diversion use cases. Now, how do we enable somebody like Chris, who's a power system engineer? He's not a software developer. Actually, his background is not software or power systems engineering either. His background is as a physicist. So how do you take a physicist who fell in love with the power system engineering world to create new applications? And what he is doing is starting to build that based on gaining meaningful access to the information at hand. It's not just data, but it's meaningful information. So Chris is putting together some amazing things around connectivity models, profiling of voltage and energy based on the connectivity model, and the contextual awareness of what happens in one locale. It might be different or related to what's happening in another locale on the distribution grid. What we're doing as a company is trying to understand and profile Chris. How do we codify that? How do we take his knowledge, wrap it up into something that can be repurposed, reused? The interesting thing about this one use case is all the intellectual property around the methods and approaches are owned by our customer. So it's their IP. What we're trying to do is codify it. We want to capture that knowledge. That knowledge is another set of data. Because the next aspect we're facing with is looking at skills gap and skills shortage. Now, I think this slide was put up by our marketing team just to play with me during the presentation, because I went white the first time I saw it. For those that know me, I am going to be a grandfather this year, so I'm quite proud, looking forward to a little grandson joining the family. But on the other hand, I'm also realizing I'm the aging guy. I'm the old guy that in this picture. I'm the one that's going to be put out to pasture soon. So how do we capture that knowledge? My wife is even going, I'm not going to be called grandmother. I'm too young. So she wants to be called G-Ma. On the other hand, I'm looking for a sports car so that I can go through my midlife crisis. But this is a real problem. It's actually a very real problem. How do you take knowledge that is in the head of operators? Because if you look at the operations of utilities today, and it does transpose into what's happening with the microgrids and distributed energy resources, you have an entire army of operators that are looking at screens. It's eyeballs on screens. It's eyeballs on switches. It's eyeballs on control. How do you capture that knowledge, codify it, put it into a set of purpose-built applications that can enable the business as the population ages? So that's part of the next big focus, because you do have to transition knowledge. And that's the whole meaning around what we're referring to when you're creating data-enabled applications. The engineer in me, if I go back to that previous screen, that previous screen was a nice pretty print of knowledge captured by the customer, captured by Chris as he put that together. What is actually behind that screen is a pretty sophisticated definition of what the knowledge was, and all the interrelationships between power, between voltage, between the connectivity model. It's all described on that screen. And we've described it in such a way that it's now codified. It's going into a knowledge repository. It's now retained. It's something that can be repurposed. It's actually defining a case. And when it goes into our software, it's a part of the machine learning around case-based reasoning. So that's another way of looking at the data you're starting to capture, and how do you now codify that within your applications for reuse, for automation down the road. Now, cloud is another aspect that people look at. And again, this is going to be argumentative. Don't get me wrong, I'm a big fan of cloud services. We use a lot of those. Our customers are using it, but it's not enough to just throw data in the cloud. It's not enough to just throw analytics at it. You still have to capture knowledge. You still have to be able to codify that, repurpose it, reuse it. But more importantly, you now need that knowledge to go down to the field. And that's key. So what you operate in the cloud, you'll have to operate in the field. And that's something a lot of people don't understand. When you're looking at microgrids and distributed energy, that data is residing in the field. And we refer to it from an engineering perspective inside our company around physics. There are limitations around physics. There's only so much data you can pump through silicon, throw over the air, throw spinning disks, in order to do analysis of that information. And in the utility world, real time does mean real time. You need to make switching decisions either at the microsecond level, the second level, or the few second level. So in order to do that, you have to get around the physics. You have to be able to take that intelligence you've now captured in the data center, move that out to the field into a distributed and federated environment. The other key in all this is that the data that's happening out in the field won't be owned by the utility. It is truly a federated environment. Those that are operating microgrids, those that are operating distributed energy resources, they're going to be the masters of their data. How do you incorporate that into intelligent decision making so you can get into the world of automation and predictive automation? So one of the things that you need to do to consider this is not just a data strategy. And it is a data strategy. It's not a data solution. It's not one product. You're going to have a data strategy. That data strategy will expand from the cloud through your data center, because you still have to operate in NERC SIP zones. You still have to have security implications in place. And you still have legacy infrastructure. You're also going to have to deal with data that's now going to be generated out at the edge and play with it at the edge itself. That's what we start to look at from what's the long-term vision of the data, the analytics, and the applications. And you do want to get to automation and predictive automation. Those are going to require what we call software-defined operations. I talked about the eyeballs. It really is a very manual, intensive effort today. Those eyeballs are going away. What you're going to do is shift from the people doing the work to the software doing the work, and having the concept around virtual operators performing this. And that's going to be part of the future ecosystem. That's all what software-defined operations is. It is a shift in thinking. There's some great benefits to this. Those benefits are going to go into not just efficiency in the operations side of the business. It's also going to be safety, reliability, revenue. And as you heard today from the panel, microgrids and distributed energy resources, distributed storage, and even the miniaturization of technology. That miniaturization of technology is making it more efficient to start to distribute the load. Even manufacturing. We worked in some of the manufacturing side, and manufacturing is now going from big factories to smaller factories, which will shift the energy requirements as well. You need to be able to accommodate that. So the adaptive utility is going to require data-enabled applications that make sense of data, no matter where that data comes from, but also out at the edge, and we'll have to have the ability to automate that and do predictive automation around that. So there's a lot of key advantages around data-enabled applications. And it may go in the face of just a pure big data approach or an analytics approach, but we firmly believe that you need to be able to codify that knowledge. And it is going to be important. There's a lot of value in this. It's harnessing the power of data. Don't get me wrong, data is important, but there's many forms of data. Those forms of data do include the knowledge that you're going to be capturing. It does include the knowledge on behavior of systems, processes within the business. And that's what this is going to be enabling. It's going to be a journey. We don't suspect that there's a silver bullet, but it is a journey as you go down the path of creating a data strategy, layering applications on top of that, making sure they're purpose-built, making sure they're tied together. They have to operate together. You don't want point solutions. That's why the platform's important, and a common view of the information is also important. So I do want to leave a lot of time for questions, but one of the other aspects that we're doing as well is taking that cloud concept. So that application that you see that Chris had built, which is actually pretty cool, because I'm looking forward to following him up with him. I won't be surfing, but I'm hoping to drive a sports car out to go see him. It's how do you take that knowledge that can run in the data center, which is running today, as well as in the cloud, but run it on one of these devices. Because that's what's going to be out on the edge. That's what's going to be stuck inside a distributed energy component and communicating priority information back to other components that will be feeding into something that Chris actually built. Chris is not going to know how to run it in here, but the whole concept around platform is taking that knowledge all the way through the ecosystem and being able to run it on here automatically. So I've got to watch time. I think I've got about 10 minutes to answer questions. I do want to answer a lot of questions. I see one over here.
Okay. I don't know if everybody can hear me or not, but David Keyes with S&C Electric Company. First, great presentation. Thank you for sharing your insights with us. And I'll wait for the microphone. Yeah, sorry. So, yeah. It's always great being the guinea pig on the question. So I'll ask the second question because the first one never gets asked. So first, great presentation. Thank you very much for sharing your insights. I agree with a lot of them. Secondly, I promise I'm not a conspiracy theorist. I just want to hear the answer to the question. Okay, so a lot of what you talked about is using data and finding the data. And so first, what are your thoughts on ownership of the data? And then secondly, as you aggregate it and you start making larger and larger data sets, what happens to the ownership of the originators of that data as you're going through there? Because BitStew is a data aggregation company, so how do you handle it?
We do a lot of data aggregation. We do a lot of correlation of complex data. Our view of the world, and I alluded to it a little bit, is that the data will be federated. And that means the ownership is going to be in the hands of people that are generating the data or have authorization to collect that data. It's not something we believe that you'll be able to get all that data into one place. That's going to be difficult. And this data problem has been around for decades. It's not brand new. The utility industry is making it more pervasive because of the fast movement into AMI, distributed operations, and that complex machine. But data will be owned by the people that are generating. If you're looking at data ownership, consumers are owning data on their energy consumption within the home. They may be implicit rights for the utility to use that in certain contexts, but there's a whole movement to establishing where that data is owned. The other aspect is going to be distributed energy resources, microgrids. They're going to generate their own data, and it's up to them whether they're going to share it. Europe's a perfect example of that federation. Europe's in a lot of regulatory debate right now. We've talked to quite a few of them on whether it's going to be the DSOs, the DNOs, the DCCs, or the retailers. Ownership of data is one of the big challenges that they're facing today. The AMI meters that the DSOs want their hands on so badly is going to be owned by the retailer. And it's up to the DSO or DNO to be able to buy that data in order to use it. And they're actually making a very conscious decision. How much do I need? Where do I need it? And how am I going to pull it in? Because now it's going to drive a lot of your algorithms and methods around profiling. Can I get sample sets of information? Can I correlate that enough in order to drive what I've learned over here in new cases over in other places? So data ownership, I think, is going to be a federated solution. not one person owning that. But it's a good problem to have, but it's something that you can create solutions around. Another question?
So I think it's really important that we understand as we develop these technologies and implement them to understand what the customer actually wants. And I think in a lot of states in their regulatory reform process, they're saying, I mean, these are leaders. They're saying, we're reforming the energy vision. We have a new vision of the grid. We're going to modernize the grid. But I don't really know if consumers have had the full opportunity to say, this is what we want. And I guess my question is between the data that you're able to collect and the priorities of consumers, how can we figure out what the reformed energy vision is of consumers before we go through changing all of our regulations and processes?
So that's another good point, and it's going to go into a strategy that I think utilities are going to have. And not just utilities, it's all the participants on this distribution grid, whether that be the low voltage networks, the medium voltage networks, or even the high voltage. I don't believe today that we know what consumers in the market is going to need, even 2 years down the road. I think it is going to change fast. As part of the reason that we're now looking at the concept of what I heard today was micro applications. If you build micro applications that are adaptable over time, you will eventually get to the point that you need to get to. If you try to build a monolithic application and what you perceive the requirements are going to be for what consumers want, for where the market's going to be, you'll probably miss the mark. We're not that smart about knowing where the market's going to move and what the dynamics are going to be. Looking at the miniaturization of technology is making it very cost efficient for energy storage. It's making it very cost efficient for energy generation at a micro level, which will change consumer behavior, which will change the utility that's servicing the consumer side of it. So I don't think you can know ahead of time. The trick is to allow the utility to adapt in near real time for the changing demands. And that's the whole concept of having a platform in place with data that's not modeled around a preconceived notion of how it will be used. You need data that's going to have different views depending on requirements of the application. That's why you have to look at the application, because it will drive how you structure and use your data. And you have to be adaptable. Hopefully that answers.
Hey, Kevin. Thanks for the presentation. Pretty impressive graphics as they scrolled through. I like that.
The surfer dude?
A question kind of relates back to some of the discussion from the panel discussion, and also one question that came up over here. And it's really around data and the regulatory aspects of how this plays out. So, this I've been reading through this AB 327 that was mentioned this morning about what the CPUC here in California is trying to do around this whole concept of establishing distribution system operators, which is really opening the door for competition at the distribution level. As you know, data is really required to drive these things, and when you talk about kind of the micro application, it's really the modularization of some of the functionality and being able to distribute that to where it needs to be located within the overall architecture, be that at a DSO as these are being defined, or at the kind of the generation, transmission, distribution level. The data is going to be critical to make these things happen, and access to that data is important. How do you see kind of this playing out as far as, do you think there's a regulatory play to say that there has to be interoperability? I mean, we got to protect privacy, but we also got to have access to the data. And some companies want to kind of keep their arms around that. How do we open that up and make sure that entities have the data they need to deliver the services that the consumers want?
Access to data is important, and I don't want to mislead anybody about the importance of data. Getting access to it is important, but the concepts are you won't always have access to all the data you need, but you still have to operate a business. There has to be interoperability. You are having a distribution grid that's going to have distributed generation, demand response. There is going to be the need for, and I think Elizabeth pointed it out as well, is that distribution network is a machine that's becoming highly important. Europe's realizing that as well with the low voltage network discussions that are going on. And now they're all struggling with how do we gain access to data in order to make sure we have energy shaping and effective shaping of the energy on that distribution grid, both from primary generation, secondary generation, looking at two-way flow of electrons, not just that one-way aspect. So data is going to be important. I think there's going to be certain exchange standards are going to be required for access to data. But I don't think it's so much as a data ownership issue as more as it's going to be a data sharing issue. That there has to be the right authorization in order to share information that is needed for the use case that is going to be required. Again, purpose-built applications. If you're looking at power quality, for example, on a part of your distribution grid, you're going to need access to information that gives you enough insight on the frequency basis in order to manage power quality. Now, that's going to require some form of regulation around what information can be shared for the time period it can be shared. That's not going to be an easy question to answer at a regulatory level. I actually think it's going to be answered by participants in the industry itself. I think it will evolve over time. To go back to the question, we can't predict what the requirements are going to be 2 years down the road. So I think that is going to evolve around data ownership. It's going to be a hard question to solve. You do need access to certain pieces of information. Now, if you look at the Australian market is now looking at multiple sets of sensors. You've got the distribution system operators are going to have their set of sensors and meters out there, and then the retail is going to have their sets of meters out there. That's another way that markets are trying to solve this problem. But that's, I wouldn't say the most efficient way. But if you look at the evolution of AMI really came out to solve what problem? It was a meter to cache problem. It didn't really come out to solve a distribution problem. But now that it's out there and the value is seen, there is a big shift from grid operations to now look at, hey, I want that AMI data. But the folks that run the AMI network are going to basically have their blocks up, and there's going to be internal politics. It's not a clean world, so even when you get into utilities, there's still internal organizations that say, that's my data, not your data. So it's not a market, it's actually internal within organizations as well. So it's a pretty complex issue. I've got one more minute. All right. Well, thanks, everyone. I definitely appreciate you listening. Enjoy the rest of the show.